So like Florian mentioned, this session is going to be about how you can upgrade your OpenStack cloud. At LivePerson, we did it many times. So in this session, I'm going to talk about the challenges, the pitfalls, going to give you some good points, some advices on how to do it right. Raise your hand if you ever experienced, if you ever did an upgrade before. Nice, yeah. Okay, great. So here with me, I have my colleague Liran Cohen, who is leading the cloud engineering group at LivePerson. I myself, I'm the director of platform engineering. We are both around 5 years at LivePerson. This is a cartoon that was taken in the Vancouver Summit 2 years ago. It shows our geek nature. So in the agenda for today, I'm going to introduce LivePerson. Then I'm going to talk about the state of the OpenStack at LivePerson. And then I'm going to hand over to Liran to talk about the planning, the testing, and the actual upgrade itself. So first about LivePerson. So in one sentence, we created a digital contact center to enable businesses to transition from voice to messaging. What it actually means that if today you need to wait on the line, call your brands, your vendors, like call Hot, Yes, Bezek, whoever, and you need to wait on the line, then with our platform, you can just message, text, chat with your vendors without any need to wait on the line. So LivePerson was founded in '95. We are around 1,000 employees across the globe. Headquarters in New York, but we have a very big office in Ra'anana, around 400 employees in Ra'anana. We have 7 data centers around the globe. And 8 out of 10 from the Fortune 500 are customers. Here's a few of the brands. You can see TalkTalk, T-Mobile, Verizon, and the list is very long. So, OpenStack state at LivePerson today. So we started at early 2012, and today we reached that 80% of the amount of servers that are used in LivePerson running on OpenStack. We have 70,000 virtual cores, around 1,000 physical servers running on 7 different data centers with 7,000 instances on them. And a small anecdote, we used to have many more instances, by the way, a few months ago, but we did some optimization to our application, so we consume today much less resources, which is good news for us. So here we can see our path with the upgrading. We started upgrading starting with Folsom, the 6th release. It's not the first release that LivePerson started with the OpenStack. We started much earlier, but this is the first time that we started actually upgrading from. So this is all the upgrades that we did, and today we are running with the Kilo release. The components that we use today are Nova, Neutron, Glance, Horizon, and Keystone. It's very important for us to use the core components, the most stable components in production, as you can understand with a very, very big scale. Some more details. So operating system is Ubuntu 14.04 currently. Our configuration management is Puppet. Puppet is end-to-end in LivePerson. We do everything with Puppet, the applications, the deployment of the OpenStack. Everything is done with that. Our network provider is the Open vSwitch. We use the physical network switches with VLANs. Our chosen hypervisor is the out-of-the-box, the KVM. And our storage is a non-persistent. We're using the local disks on the hosts of the clusters. So a bit about the services that drill down to the services that we run on the controller. This is the controller itself. I'm not going to list the services, but you can see, of course, the data layer is the MySQL, and the message queue we use is the RabbitMQ. This is for the controller. And for the compute, of course, it's much less services, as you can see here. Zooming out a bit from the OpenStack, this is the tech stack that we use at LivePerson. As a SaaS company, of course, our web and app tier are very, very big with a lot of instances on them. And they are all 100% run on the OpenStack. We also have a very big data tier, and some of it run on the OpenStack, not all of it. And we use Logstash, of course, the ELK package to use for the logs. And you can also see that we are heavily invested in Docker and Kubernetes. I'm going to hand over now to Liran to talk about the planning, testing, and actual upgrading.
Hello, everyone. Koby, thanks for the intro. So I would like to, now that you all know more about LivePerson, the OpenStack deployment, and the history of the LivePerson OpenStack upgrades, I would like to go ahead with describing three major phases that we will need for a successful upgrade. The first one is the planning, then we will go to the testing, the labs, and the last one is upgrading your production cluster. Thank you very much. Okay, let's go. We will start with the planning. So in this slide, you probably have this on every distro supporting OpenStack versions. You will see the list of available OpenStack versions and the list of OS that you can use, the OS versions that you can use with your OpenStack version. So for example, if you are running the Trusty, which is 1404, you can use you can run ISO, Juno, Kilo, Liberty, and Mitaka. And one thing that you should take from this slide is that every OpenStack LTS version can run on two different OS versions, which is, in this case, if we will take Mitaka, we can run Mitaka on both 1404 and 1604. So for your planning phase, you should take this into consideration, that you will need to run, that you will need to plan your OS migration the same when you are planning to move to any LTS version. So when we will try to migrate to Mitaka, we will also include the migration to the 1604 version. To complete that, we should also select the right kernel, which is the LTS kernel available for us on each OS version. And the idea to choose the right kernel is to save some unnecessary kernel upgrades during the operation of your cloud in production. So for the next phase, so for the next part of the planning, we need to be familiar with the release notes. So for the release notes, it's very important to read carefully all the release notes and to make sure that you are aware of each one of the new updated and deprecated features available for each component that you are running on OpenStack. So for example, if you are planning to migrate one of your components, let's say Nova or Keystone, you should read carefully all the release notes and the upgrades notes as well. Moreover, you should also take into consideration that any third-party component that you use inside your cloud, like Open vSwitch, you should also make sure that if you are going to upgrade from one version to another together with the OpenStack upgrade, and so you need to do the same and read the release notes and make sure you are aware of all the changes that were done during the release cycle of that component. Okay, so one of the key elements for a successful cloud upgrade planning is understanding the impact of the upgrade on the actual cloud, on your cloud. So you need to understand deeply the impact that any component that you are going to upgrade will have on your apps, which is the services you are running on top of your cloud, any automations that you are running inside your cloud, and the end users that are going to be impacted by the upgrade itself. So when I'm saying end users, it's your tenants. You need to make sure, you need to work with them closely to plan the upgrade, so they will have time to get prepared with their tools and solutions, so they will be able to work after you will upgrade your cloud in production. So after we did all the initial planning, we need to choose the way we want to upgrade the cloud, and this is based on all the information that we collected in the impact section and in the release note section. So we have more than one way to upgrade the cloud, and I will list 4 options for doing the actual upgrade. And we will talk about the pros and cons of each one of the upgrade methods that we will list here. So the first one, it should be the easiest one, with the most risky one, is the in-place upgrade. The meaning of the in-place upgrade is that you are going to upgrade each one of your components live on production. So your controller will be upgraded in place, and all your compute hosts will be upgraded as well. So for the pros, the only pros that I can think of in that case is that you don't need any extra resources, and you can save a lot of planning and getting ready for such an upgrade. But a lot of cons is that it's a very risky operation. And the second one is that the rollback will be super, super complex. So if you want an easy rollback and you want to make sure you have a working cloud after the upgrade, you should take this option off the table. And let's move to the second one. The second one is a side-by-side cluster, or you can call it a parallel cloud. The idea here is to actually build a new cloud. So if you know to build, if you remember how you build your first one, you will build a new one, side by side. And this comes with a lot of pros that we can talk about them. The first one is that you can skip OpenStack versions as much as you like. You can add very huge changes in one of your components. For example, if you want to switch from one network layer to another, let's say you are moving from a physical layer to any SDN solution, you can do it in such OpenStack Upgrade method. And the cons is that it's very, very expensive. So if you need a set of hardware, you need to migrate all your workload, which it's going to be very expensive and time-consuming. Okay, for the third part, for the third way of upgrading is the controller side-by-side. I'm going to go into the details of that in the next slide, because this is the way we are going to describe the way LivePerson is upgrading the clouds. And the fourth one is something that we didn't test it yet. So we didn't test this one yet. It's the rolling upgrade. And the idea of the rolling upgrade using a new, it's not such a new, but it's something that we have in Nova, I think, from ISOs. It's called Nova upgrade levels, that you can do like an in-place without locking the RPC version of the message queue. We are not going to get into the details. We are planning to explore this one, and this should be some kind of enhancement to the current upgrade that we are going to introduce today. So once we have the planning in place, and we need to document that. We need to create a full procedure with all the steps that we need for the actual upgrade. So we will write all the steps in the procedure. We will review each step and try to automate as much as possible. So make sure you really invest the effort needed for any automation. And the most important part, you should include the rollback as part of your plan. And it should be, you should consider that with any automation available and on each step that you can afford to automate the rollback. So moving to the next phase of the upgrade is the testing. So when we are going to test, when we have a working upgrade plan, we can go ahead and test it in the lab. So what we will need for the lab, we will need a production-like lab, and this will be that we will need the same. We will do the best to take the same hardware. Of course, we will do the same network configuration. For live person use case, we are using as Koby mentioned, the provider network VLAN, so we will do the same in the lab. We will have all OS version, the same OS version, the same kernel version, and we will make sure we are mirroring every repositories that we are going to use for the upgrade. So for the time of the upgrade, we will have the same packages available. And the last one is all the tooling. We will make sure we have the same upgrade automation tools available in the lab and tested in the lab, and also the configuration management solution with the same versioning on the modules that we are using to deploy. So this will prevent any surprises while upgrading the production clusters. So once we have the testing environment ready, and we made sure it's production-like, we can apply the procedure, we can test the procedure or the plan, we can modify it to see everything is working as expected, and we should definitely consider testing the rollback as well. So for the last part, after all the boring stuff that we talked about the planning and the testing, we are going to do the actual upgrade. So for the upgrading, the last part, the last phase, we at LivePerson, we chose the side-by-side cluster upgrade. And the reason we decided to go with that approach is that because the most important stuff for us, or the goal of the upgrade is not just the upgrade itself, we set the goal of having a zero downtime upgrade for our services. So we want to be able to upgrade OpenStack without any impact on LivePerson services. So the side-by-side controller upgrade allows us to do so because we can do a very simple rollback and with minimum impact on the service. So for this upgrade, we have two steps. One step is the new controller upgrade and the DB sync, and the second one is the compute upgrade. So the first step is we are going to build a new controller with all the components that we need for the new version that we want to run. And then the second step, we are going to do an in-place upgrade using some kind of grouping that will allow us to keep the service we are running on top of the cloud available with no downtime. So for the active controller, the action that we are going to take on the active controller, we are going to take a snapshot of the cloud itself to make sure we have the state of each one of the instances running on the cloud, so we can use it later on to understand and to realize if everything worked as expected, and we are going to compare the two once we will have the new cluster ready and functioning. The second step that we are going to take is we are going to shut down all the services running on the controller in a graceful manner to make sure everything is ready for the sync of the database migration. We will sync any data, images, and database that we need from the old controller to the new one. And on the new controller, we are going to import these actions we are going to take for each one of the services running, or we are planning to run on the new version. So we are going to do the same for Nova, Neutron, Keystone, and each one of the components. We are going to import the database. We are going to update the version, the schema version, to the new version of the OpenStack release that we want to migrate to. We will start the service which was migrated. We will check it. We will do all the API checks needed, and we will review the logs to make sure that we have a successful service running, migrated and running on our controller. So this one is, we are going to take these 3 steps on each one of the services. For the compute, we are going to upgrade some subset of compute that we call a testing group or a control group. After we have that control group in place, so this is the actual upgrade. We are moving, in this case, we are moving 2 computes to talk with the new controller, and they all share the same new version. So you can see we have a new cluster running with the new version with 2 compute, which are the control group. Once we have this one in place, we can go ahead and do all the testing that we need regarding all the automations and all the automations that we have on the cloud and the daily operations that we are used to run on production. So let's say we are going to create new instances, we can create new networks, subnets, etc., and make sure everything is working as expected. While we will do so, we will also monitor the new cloud, and the monitoring of the new cloud while upgrading is very critical and should be done while you upgrade your cloud. You need to test the API response time to see that there is no load on the database and there is no impact on the message queue, that everything is working as expected, and that you can go on to the new group or to the next group. The reason we are splitting the groups, the compute to different type of groups, is because some requirements we have from the application. We can't do any static availability zones, so we developed some tools that can discover any service that run at live person, and we can make sure we can group them into mini availability zones, a very dynamic availability zones that will allow us to do a full upgrade with 0 impact on the service. So we will be able to lose any group and still have the live person service running with no downtime. And that's the reason we are doing all this grouping. So everyone that is already using the availability zones available from OpenStack can map these groups to the availability zones and make sure the service is working as expected for availability zone redundancy. So once we complete all the groups, we have all the nodes running, all the hosts running on the new controller, and the upgrade is done. What we are doing once we completed the upgrade, we are going to do all the set of tests that I mentioned earlier on the control group, on the final upgrade with the new controller and all the nodes and make sure everything is running. I would like to mention as well that while we are monitoring all the APIs and all the OpenStack components to make sure everything is running as expected, we will also do a full monitoring of the live person service to make sure we didn't have any interruption or any downtime for the users. And that's it for the upgrade. We finished the upgrades, and it was a successful one. And Koby will continue from here.
One more slide. Yeah, you need to remember that the upgrade process can take a very long time, sometimes even a full day from the early hours of the morning, 4, 5 a.m., until the late hours of the evening. So you need to take care of your people, feed them, and at the end, celebrate properly. Very important. Okay? Thank you very much. I want to also thank the group that does it, actually. Diana, Nadav, Tomer, Omri, Oren, Erez, and Liran. Thank you very much.